My name is Jeremy Bartlett. I'm with RMF Engineering based out of Baltimore, Maryland. In a past life, I was a network administrator for an oil company that kind of lended its way into a more recent past life, which was installing and programming building automation systems for Johnson Controls, Automated Logic, and most recently I've been getting into and programming Tritium Niagara AX systems. So naturally, when I made the transition over to the commissioning world with RMF, being a full design firm and also having an extensive field department with commissioning, retro commissioning services, they've also rolled me into the position of doing QC of controls integration, sequences of operations, and building automation system integrations for our building and infrastructure design teams. So do quite a bit of different things, wear a bunch of different hats for RMF, but my main focus is on commissioning. It's what I love to do, and mainly focus on retro commissioning and new project commissioning. We're much like you. We've got a lot of different customers, and all our customers have a lot of different thought processes on what they want in their buildings and how they want systems to work. There's more than two. I'm going to break it down to the two most common that we come across, and we do have customers that do not want to integrate laboratory control systems. And they do it for a couple simple reasons. The most recent project that we're working on in California right now, they've got limited knowledge on with their staff that are serving these systems. They don't want their staff to be looking at how laboratories are being controlled. They don't want them looking at airflow rates or having the ability to change anything in the labs, and they want it that way to protect their facility staff. They don't ever want to get blamed. They want to leave the lab control portion with the lab staff, and they leave it at that. A lot of facility staff, and even scarier, some laboratory staff, don't understand the complex program requirements on what the lab requirements are needed as far as temperature, humidity, and air pressurization and airflow. So there's certain people we don't want to have that information. It's very simple. Integrating a lot of different systems comes with a cost. We all know that. There's additional costs, there's additional hardware, there's additional programming time. Sometimes they don't want that additional cost. It could be VE'd out of a project. They're just not part of the original project requirements at all. This next one's a big one, and me being a former control person, I used to get blamed for everything on any kind of building that had any integration. The integrated systems are difficult to service. When something fails, does the owner know who to call? Are they calling the laboratory control techs? Are they calling the Johnson Controls or Siemens control techs? Whose issue is it? Where are we going? And we'll talk about how to sort this out later on. But that's a big turnoff for a lot of owners. It's stressful. They don't want to have two different service contracts, and it can get pretty complicated. And they don't want to be inundated with data. Anybody here have customers that have control systems that are slow? Right? The more data that you have on site, the slower the network could be. We're going to talk about this as well. There's a couple success stories that we can point to and a couple things that we can point you to pay attention to help ensure that we don't get those slow networks. Then you have customers that want everything. They want every point that you can get. It doesn't matter what it is, if it makes sense, if it doesn't make sense to have these points, they just want everything under the sun, everything integrated, every system. And you can argue that it adds an elevated level of safety to your laboratory systems, right? So if you have some advanced alarming, you could, if you have airflow issues, if there's not any kind of localized panel at the laboratory to warn the staff, if you're detecting that there's any kind of fume hood flow issues, if you have the staff capable of monitoring and responding to those kinds of issues, we can dispatch them pretty quickly and warn the occupants, get them out, and find out what's wrong. So in a lab situation, that's a critical component. Integrated systems are allowing for a lot of advanced energy saving strategies, which we'll be talking about. And this next one's not a typo. Everyone has this concern whether they want the data integrated or they don't want the data integrated. They still have the difficulty in determining whose fault it is when something breaks down. So no matter what customer you have, that is always a concern across the board. But they always want that data. Bring in everything, bring it all in, and that's not always a good thing, and we'll talk about why. First step, in my opinion, on successful controls integration is really teaming with a bought-in owner and design team. If you don't have an owner that's going to assist you in pushing the design team to get comments and resolution in when you start doing your design review and submittal reviews, it's really not going to work. We can make comments left and right all we want. I mean, we put forward quite a few integration comments when we do all our design reviews and submittal reviews, and we still end up with projects at the end where it's not addressed. If you don't have an owner and design team that are going to assist you and really use us for what we're here for, it's not going to work. They have to be bought in. We're starting to put more advanced controls integration verbiage into some of our OPRs. We're defining what types of systems are going to be going into the building, but we're also taking it in some cases down to the level of what points are going to be available and what types of points those are. Are they read-only? Are they writable points? We're getting pretty defined in the OPR, and we need to because we're not getting what we ask for in some of our projects. The most painful part of this whole process is the next item, which is living in the specs. How many people like reading specs? Anybody? Yeah, I've got a very good friend who's a head spec writer for a competing engineering firm, and that's all he does all day long is write specs. And I don't know how he makes it through the day. Talk a little about the organization and design of our submittal reviews. It's pretty simple when you think about it, but it's a very useful tool the way we've been laying this out. And then I was in on the K-12 meeting yesterday, and I was really happy to see them talk about a push for a controls integration meeting. This is something that when we go and present or interview with a client for, we are starting to push for as a mandatory component for a successful commissioning project. So we'll talk about what goes into that. Talked about teaming with a good owner and a good design team. This is just a sample of a design review comment, and looking back, this was a comment I made 5 years ago when I first got into the commissioning world, and I was still pretty impressed with the way I wrote this comment that long ago when I wasn't quite sure what I was doing. But I was reviewing a boiler submittal, and it was very vague on how it was going to connect to the system. It talked about mod sync via backnet communication. The control submittal talked about backnet over SC bus, and we clearly identified that it wasn't clear how these systems were going to integrate. There was options provided, nothing was clearly identified. We put this issue in front of the owner, we put this issue in front of the design team, nothing happened. This was for a very small boiler replacement project up in Narragansett, Rhode Island, and bottom line, nothing was addressed. The controls contractor was getting blamed for everything. The control panel wasn't communicating back to the Johnson control system, boilers weren't being sequenced properly, and the end result was 2 additional site visits, which does not sound like much, but when the entirety of the project was for 2 site visits, that's a significant extra cost to the owner. And that's not just for myself and the commissioning team, but for all the other contractors that were involved. So additionally, not having that boiler system up and running, they were obviously putting it up in the summer months. This particular laboratory had some fish hatcheries where that processed water was critical to have up and running by a certain time frame, and it was missed. We didn't get the boilers up and running in time. So again, if anyone paid attention to this comment when we first put it forward, we might have been able to address it early on. Developing a strong OPR, and can anyone give any feedback? How often do you have an OPR on a new construction job? Very rarely. We're pushing for it more and more, but I don't know, maybe 1 out of 10 jobs we actually have an OPR. And when we start talking about it early on in the process with the owner, it's, well, we don't really need that. We've worked with this design team before, not quite necessary. We all go through the same thing. So, we really need to start pushing for that. And we really need to start defining, especially when you're getting into these complex laboratory systems, you need to start defining read and write capabilities as well. So you can get all the data you want from control system or laboratory control system A. If you can't write to any of those points and that was your intent, what's the point of integrating it? We're monitoring only. It's not going to be quite useful to us. Defining communication protocols. We'll get more into that in a few. And we could do a whole different technical session just on communication protocols, so I'll be touching on it and putting out some gotchas, but that is a totally different training session that we could get into some other time. But oftentimes they're very loosely defined or not defined. Piece of equipment shall connect to the energy management system. How? If we don't define it, is it hardware points? Is it some sort of integration? We need to define how that is all going to be addressed in the OPR. And we also, in that OPR, push for the integration meeting, if we have an OPR. Living in the specs. When I first started doing design review and control focus reviews, when I moved into the commissioning field, everybody under the sun in my company always brought me the control submittal and said, here you go. Because that was my background, that was my specialty. Very quickly, we realized that that's not enough. Because you could have a lot of information in the control submittal, but if the equipment that's also being submitted on is not matching up and aligning with that, you're going to run into issues come time for implementation. We'll go through a couple sections here shortly in a couple slides, but I mean, you really need to be spending your time reading through every single system specification in a project. If you're not doing that, you need to be, and identifying where there's holes. It's the only way that we can accomplish the task here. Integration type we talked about, and we're starting to ask for submittal sections in the specs to require the different equipment vendors to provide I/O lists for any of their integration components. So when we get a submittal in from a boiler manufacturer, and I have a sample of a very good one that has come through, I want to see everything. I want to see all the points that are capable, and I want them to at least attempt to identify which ones are read and write capable. So the first thing we're going to do is highlight the system being reviewed, which is, as I said, all of the systems. Right? We're not doing a sampling here. We've got to review everything in the building. We're going to identify the system type identified. Okay? So in the controls submittal, it might be one type of technology. In the equipment submittal, it might be more generic, and it might say something else. We're going to highlight what those discrepancies are. We're going to then identify our concerns on what we found. And then we're going to start tallying all the integration points and where they live in the individual contract documents. We do that step first, and then we push for our controls integration meeting. This is where we want to get, and we typically do have two of them, much like they identified in the K-12 seminar yesterday. We want to do one early and up front with the design team and the owner to say, hey, here's where we know that we have issues. Mr. Owner, are you okay with some of these lapses, or do we really need to push for these additional points to be included? Then when the submittals start coming through, we like to have a second meeting where we start bringing in the individual contractors, and we try to get everyone at the table. You know, obviously you want the control contractor there, but all the different equipment vendors all need to be at the table, and we need to hash things out and make sure that we have all the different components selected. So many times I'll get an equipment submittal, and it'll have this little section that says, can communicate over the following protocols, and then none of them are selected. So we have no idea which one's being provided. So we need to identify those and sit down and talk with them and say, your system needs to be provided with, you know, A, B, or C. But the ultimate goal is to really get that open discussion with everyone to try and get this addressed early on, because once it's being installed, it's not too late, it's never too late, but there's additional cost with additional integration hardware or specialty systems. We want to see if all the systems that are intended to be integrated are covered by the specs, as we've identified in the OPR. Make sure that the communication protocols are specified and consistent across all different specification sections. Identify if communication is even possible. We've had systems where they come in and they say, well, we need hardwired outputs from this piece of equipment to the control system. Does it actually have those spare outputs? Is it connecting to multiple systems? Is there a fire alarm system that's connecting back to a local fire control panel? Can it also talk to the BAS, or is that point already taken and used up? So is it even possible? And is it on their radar? How often do you have a controls contractor put a submittal through and there's no mention of water metering because they didn't go back and look at any of the plumbing drawings and see where we have water meters located throughout the building that have that tiny little tag that says to building automation system, or shall communicate to, or whatever it happens to say. They're not going to review all the drawings, because when I was a controls contractor pulling it all together, I didn't do that. I didn't. But there needs to be some clear delineation too of who is controlling what components. So if you have packaged systems, how much of the equipment that's in that packaged system is controlled locally versus can be controlled by the building automation system. And again, provision for supplying integrated points. The read-write points are critical when you start getting into some of the advanced control strategies. So we put all this information together and we start doing our controls integration review meeting. And we lay it out very simply. Spec is requiring all these different systems to be integrated with the controls. Okay? So when I read the specs, every spec session has that related specifications that are intended to drive us to look at other areas of the specifications. In my opinion, those are lacking and inconsistent across most specs that I read. Typically, the controls spec will be the most extensive, pointing you to different areas. But more importantly, the equipment specs don't always point back to the controls. So your equipment manufacturers and vendors aren't always picking up on what the requirement is on their end to communicate out to other systems. So we identify that this is this is a sample for a large complex we're doing overseas where there's, I think, 6 or 8 buildings being constructed all at the same time. So a lot of different specialty equipment that's going in here. So I don't know, spend 2 weeks reading specs on this particular project. It was painful. But then we start highlighting some other issues, sections that do not mention integration but are identified in a points list that may be there, or in a drawing that may be there. So we had a couple. Meters and gauges are missed quite frequently, in my opinion, because most don't go back to the plumbing drawings, like I said. So we identify where there's potential lapses. And then items that are completely missed. This particular project had a very solid OPR and a very solid standard, and irrigation lighting control systems are standards they put in on all their locations. Those were not addressed in any of the spec sections, any of the control sections. It was completely missed. So we picked up on this during the design review. We got it back in, and it was put back into the final documents before it went out to the contractors for bidding. How the communication protocols are specified. This is a really tricky subject, and the more educated folks at my company slap my wrist all the time for being too specific when I'm reviewing some specs. I think some designers intend to have things a little bit more open to cover all their bases. But from my point of view, when we're integrating something, we can't let that happen. Otherwise, we're going to have that additional hardware and programming time at the back end. So, what networking option is specified? You've got Ethernet, ArcNet, MSTP, and RS-232. You can put the word BACnet in front of any one of those, and that's a different communication type and a different type of wiring that goes back to the building automation system. So if we just write BACnet compatible and everything's BACnet, well, what does that mean on site? Does the control contractor need to provide some sort of Ethernet ready device? Is it capable of an RS-232 serial connection? What are we getting at? So the simple term BACnet is, in my opinion, very open-ended and leads to a lot of confusion on site. Again, we talked about, is communication even possible? So most typically where we find issues is where we have fire alarm systems or any kind of power monitoring, where there's a centralized power monitoring system. Not every control system that's being put in can communicate out to 2 different systems. There's limited options. We need to review that. And again, these are usually conversations we have with the owner. Is it enough to get a general fire alarm notification to the BAS? Do we need fire alarm hardwired shutdowns back to our equipment? Is that possible? Are the points there? Power monitoring. Do we need that at the BAS if we have a separate dedicated power monitoring station? Depends on who's servicing the systems and what the owner really wants. So we need to have all those discussions along with the owner to find out, is it an issue? Do we want to add the additional hardware? And the whom is controlling what? We're very vague sometimes in how things are specified and documented on the control on the plans and on the control sequences. And we really need to be clear on whom is responsible for what components. Can we actually integrate to a package system? And if we do, are we controlling anything? Are we doing temperature reset, flow reset, anything along those lines? Or is the package controller going to handle all of that? Example of that is another boiler replacement project. And we have a lot of issues with integrating the boiler controllers all over the place. Whether it's a standalone boiler or if it's a boiler with a centralized boiler control panel, there's always confusion across the board. And it's something that we've really been focusing on lately, and I still don't think we have it straightened out all the way, to be completely honest with you. We're getting there, but integrating to boiler control systems is still a challenge for us. So this is just a snippet from the boiler control submittal where they have this nice little optional control valve. So it wasn't circled as being a component that was being supplied. It wasn't lined out saying this wasn't being provided. It was optional. So And I have to defend myself. I was brought in, I said I wore many hats. I wasn't commissioning this job. I was brought in as a condition assessment after we had some control issues on the boilers. So I started going back and reviewing all the sequences and submittals and everything before I went out to the site to see what was going on. And I found this optional control valve. So the complaint was actually our boilers keep tripping off on high water temp. Okay? So saw this optional control valve, and I said, okay, so I need to find out if this boiler came with this optional control valve. Is that the problem? Is it closing? Is it not opening? What's going on? Then I go to the control submittal, and I start reading the control sequence of operation, and they very clearly identified on the left-hand side of the drawing, and it might not be clear in the presentation, I apologize, what points were being integrated by Modbus, but what was not noted as being integrated were the boiler isolator control valves that they had command and status over. So then I read the control submittal and say, well, they're controlling the isolator valves. And there was some sequencing for the building automation side of the house on how to enable the boilers based on isolation valve position. We get out onto the site, and what we found is that the boilers did come with their own valves, and they had a proprietary wiring harness tied back to their boiler control panel. The boiler control valves and their positions and statuses were not points that could be integrated back to the building automation system. The building automation system was trying to fire boilers when the valves were closed. We kept tripping off on high water temp. This was a high-profile building down in DC with some very high-profile banking executives, and people were screaming everywhere. So again, you do your boiler replacement projects in the summer, things were starting to get delayed. We were starting to get into that heating season, and we couldn't get the boilers to run. So we couldn't integrate. The end result ended up being increased project delays. We had to do some design modifications to modify the control sequence because the control contractor is not going to change anything until he's directed to. So we had some change orders there, revisits to the site by the entire project team, and retesting of the functional performance testing with the commissioning agent on site there. So again, when we're reviewing these, who's controlling what? It needs to be clear. And those are key things that we want to look at when we're doing design review. Again, this is what we're wanting to see. We're starting to ask for this now in the specifications and asking the owner and the designers to put in a requirement to add these parameters. So this was a pretty extensive integration points list that came from the boiler manufacturer, which was very helpful. Still didn't give me what I wanted, which is what's read-only versus what's writable. But it was a start. It at least gave us the knowledge that we knew what was coming back to the system. Again, different configuration options that came with it. They're telling us what type of control signal here. 4 to 20 can change the header temperature set point. It tells us what network communication types are capable of being integrated to. So this is what we're starting to ask for, and this is what we're starting to see. But this is what our design review layer looks like. It's simple. It's a spreadsheet, right? It's basically starting to look at a system-by-system evaluation of the entire building, the entire project. We are, let's see, I don't know which one's my pointer here. But anyway, up top we have a system description, and then I have an integration type. This particular one, again, it's a little hard to read, but it says, based on what I read in the specs, it said integration type was hardware and either BACnet or LAN talk. So that's what this dedicated heat recovery chiller said it would do. But then when we read further in the specs, the spec and the information on that dedicated heat recovery chiller didn't require any kind of hardware points to be output. It didn't very explicitly say what was going to be communicated out. So that was a concern I had when we started doing the design review. This was a particularly nice design where it had an extensive points list that lived in the submittal, in the back end of the submittal, so I was able to pull all that data. And then when I start doing the drawing review, I start back checking to see what points were addressed in the drawing versus what's been left out. So the fact that this piece of equipment had pump start stop and pump status in the points list, but had nothing on the drawings requiring that as any kind of communication point, hardwired, integrated, whatever, it wasn't addressed in the drawings. So we start highlighting those issues and putting it back to the design team saying, let's tighten this up. Okay? And then we get a second chance when the submittals start coming through. So what I like to do is, again, if I have a specification points list, that always lives there. You don't always have that. It might be something that comes just from the drawings only. But you can see I have a lot of things here that just say not listed over and over again on the drawings and the controls submittal that came through. So it's an easy visual reference to kind of look across and say, all right, well, we have something that's required in the spec. It wasn't in the drawings, and now it's not in the control submittal. Well, come on, let's get on the same page. What's required? Let's get these points in. Let's see where we're at. So again, this is something that we turn over in our second controls integration review meeting, where we get down with all the contractors and say, hey guys, we got holes. So can this be buttoned up? Can it not? Can we get these points integrated or not? So the role in design review in the construction phase, I mean, we're really being relied on now from what we see to help drive this. When something doesn't work at the end, we usually get the, hey, Mr. Commissioning Agent, why doesn't this work? You were paid to make sure that all this stuff worked together. How come we can't communicate with these points? How come we can't communicate with those points? I have a success story about a laboratory in Ohio where we had a mass quantity of data points integrated back to multiple control systems. And the network speed was, I don't want to say flawless because nothing's ever flawless, but it was not slow in any way. But that's only the case between the hours of 6 a.m. and about 1 p.m. And then everyone goes to lunch and comes back and it's on the rest of the network for the entirety of the building. And everyone starts shopping and looking at stuff online. And the system crashes every day about 2 o'clock. So it works perfectly fine during the day, but it's when everyone starts kind of messing around in the afternoon, getting ready to go home, that things start happening. So there are other things on the network, depending on if it's not an isolated network, but there's other outside influences. Some building automation systems are sized based off how many data points that they can handle. I know Johnson Controls is one of them, where they have a certain number of points per controller. We do. And again, it's partly because I'm more familiar with the system than most, but I'll do calculations on the number of points per device to see if we're getting towards any kind of max capacity on a piece of equipment that's being provided. Same thing with any kind of network trunks. If the max quantity of field controllers on a network trunk is 100, and the control contractor puts 99 of them on a trunk that leaves no room for expansion, we'll highlight that and suggest that another secondary controller be put in to allow for future expansion. But again, when we're talking about integrated systems in particular, you're talking about a lot of data points. And when we talk about data points, it's not just the inputs and outputs, it's the set points, any kind of binary values, trends, totalizers, any of that data that gets integrated from a system back to a BAS is considered a data point. So you start getting some pretty big numbers when you start integrating a lot of components back. The building automation systems refresh based on COV rate for the most part, and COV is change of value. So I learned this the hard way on a project when I was installing it. We had a couple hundred VAV boxes on a very small network, and the network kept crashing. Got on the phone with tech support, and they called me, and they said, well, what's your COV rate? And I had never heard the term before, and by default, the equipment vendor I was working for, COV rates out of the box were set at either 0 or 0.1. Meaning anytime any analog value changes by a value of 0.1, it sends information back across the network. That's excessive when you're talking about airflows, pressures, anything that varies, temperatures, humidities, anything that's varying. You need to pay attention to those COV rates. So I'm not suggesting that you go out there and mandate what the COV rates need to be, but it's a valid question to be asking when the controls contractors doing their equipment checkouts and start doing their point-to-point is, what are your rates set at? As an example, one of the vendors I work for had a published recommendation for COV rate setting, and the value needed to be set at 10% of whatever the full flow was. So if we're talking 10,000 CFM, what's our COV rate? It's a big number, and it's not 0.1, right? So that data communication, that excessive data transmission going across the network was bringing down the network. So as soon as I changed all the COV rates for all the VAV boxes, the network ended up staying up. So something that's always in my mind when we're looking at these systems here. And this is, in my opinion, one of the most difficult parts of any kind of integrated system here, especially for the owners. And it's, when something fails, whose fault is it? Who are we going to call? Do I call the Johnson Controls guy, or do I call the Phoenix Controls guy? And it's what we really need to do, and what we start doing is we start considering, we go and we visit flushing tests and pressure tests and everything else, all these other field tests. We'll go out and we'll consider watching the controls contractor perform their integration to the other systems as another system test that we need to start witnessing in the commissioning role. So we'll ask the owner to back us on that and start letting us be part of that process to see how the data comes across. We have to witness it to see how it works. And the reason is control systems are all different on how they move data. Lab control manufacturer A, okay, I'm trying to be generic here as much as I can, worked on a laboratory system. The way their data worked when it comes to integration is their local lab control server pushes data out to the building automation system. So if data is stale, not refreshing, is dropping out, in that particular instance, any time data fails, it's not the control vendor's fault, it's the lab control vendor's equipment that needs to be addressed to find out why data is not being pushed out. Something's wrong on their server. But that's not the case with everything. I have other lab control systems, we'll call them lab manufacturer B, where they rely on the building automation system to pull data from them. They don't do any data pushing whatsoever. So I'm not going to give you an answer on how to manage this and how to really determine whose fault it is. You really need to witness how these systems are being integrated to see how the data is appearing. And then we'll do simple tests. We'll go and we'll flip off the lab control server and see what happens. We'll turn it back on. We'll see if that data gets pushed back out or if Johnson Controls has to restart their server to be able to go out and pull the data. We're starting to put that into some of our functional testing when we start getting into some BAS testing. But the whole point of integrating all this stuff is twofold. It gives you more flexibility in how you're maintaining and managing your building. It gives you more data that you can use for a number of different things. This is a Albrook facility, EPA laboratory in Cincinnati, Ohio. They just conducted a 5-phase infrastructure replacement project that took about 7 years to complete. We were asked to come through and recommission the facility at the end, and part of that recommissioning at the end was an extensive laboratory integration project. We're getting to the point where we're starting to commission software, is where we're getting now. Replacement of a few air handlers, about 2,000 office terminal boxes, and about 2,200 laboratory terminal boxes. So again, you start thinking about what those data points mean. All the flows, all the flow set points, all the trends, all the temperatures, all those different points being integrated back to a system, right? One of the first things we did, this was a Phoenix control system we went through, and anyone who's familiar with the hardware knows that they don't truly read airflow. They work off of a differential pressure. So we installed the contractor installed differential pressure transducers across all their exhaust air valves and mapped them back to the Phoenix system. And Phoenix control valves require a minimum differential pressure to guarantee accuracy over their spring, right? So we actually brought all those points back, integrated through the system, which is all those data points on the far left side, and we ended up putting in some control logic to look at the worst case scenario box. If anything was starting to drop below and if someone knows this offhand, is it 0.03 inches? Does that sound right? 0.03 inches is the minimum required DP? I'm sorry? 0.05? Okay. We put in some logic that said if anything starts to drop below that 0.05, we start ramping up the exhaust static pressure reset. But if everything was satisfied, we'll start reducing it. So we were able to reduce the exhaust static pressure in the system from 1.5 inches to 0.8 inches. And when you're talking about, I think it was 12 or 15 dedicated laboratory exhaust fans that were all benefiting from this. Didn't take it to the step of calculating the energy savings yet, but we're getting there. So it's significant savings so far. We're starting to do a lot with fume hoods and laboratory operation alone. We have clients that think you can't save energy in laboratories, and we all know we can. There's a lot of different things that we can do. We're starting to get into automatic sash closers. We're starting to put those in with some presence detection. Alarming off of fume hood information if a sash is open for more than a certain period of time. This particular site, it's integrated to a work order system, so if a sash is open for more than 24 hours, a work order is generated and someone's dispatched to go take a look at the fume hood. I mean, when you're talking about hundreds of fume hoods in the building, this starts to make a lot more sense. So again, if we weren't integrating all the individual points back from the laboratory control system, we couldn't safely monitor this and service it properly. And this is a second system. So if I go back one, I talked about those ugly air handler graphics in the beginning. I told you they did a renovation project and they changed all the graphics. This is the new Johnson Controls system. I'm not selling them. I'm just saying that's what it looks like, the new style of graphics they have. But while they were doing that, they also chose to implement a Phoenix dashboard. Has anyone worked with a Phoenix dashboard yet? If you have any clients wanting to do it, caution them. This was the first installation that was not a beta site in the country, and it took quite a while to pull off. But we're actually calculating live air change rates in the laboratory. I was tasked with going through and measuring the sizes and verifying the size of all the labs. We implemented that into the software. So all of those laboratory points that are integrated to the Johnson Controls BAS, all the trends, all the data is also integrated from the Phoenix macro server to a separate Phoenix control dashboard. So we have two lab systems monitoring all the laboratories. So every point's getting hit twice. But we managed all our data while we were putting in. So we were talking about 9,000 data points across 280 labs. And all 9,000 data points were integrated to two different control systems at the same time. All were integrated to Johnson. All were integrated to the Phoenix dashboard. We didn't trend all the points, but we had about 2,800 by last count that were also being trended by both systems. So again, more data transmission, pulling information back. And other than the afternoon shopping sessions, the system is up and functioning rather well. So if you pay attention to the way all the data is integrated and mapped in, you can be successful with this. So I believe I identified the steps in the controls integration here for you. And to ensure the proper controls integration, identify some target areas for design review and give you some ideas on what to do. Identify the role of commissioning during our design review, and lastly, identify some potential energy savings strategies in some laboratory environments.